In this video, we are going to look at angles in standard position. There are a lot of definitions we are going to look at, but before we do so, let's again look at the unit circle. So here we have the x and y axis with a circle of radius 1, which makes the unit circle. We have an angle here formed from the x-axis, the positive x-axis, to this line that starts at the origin and goes to a point P on the unit circle. When we start at the positive x-axis and go in the counterclockwise direction, we say that the angle theta is positive. It is greater than 0. When we start at the positive x-axis and we go in the clockwise direction, so we go in the opposite direction, we say that the angle is negative or less than 0. We call the positive x-axis, in both cases, the initial arm. We call the line that joins the origin to the point P on the circle the terminal arm. So our first two definitions are the initial arm and the terminal arm. A standard position angle is one that starts at the initial arm on the positive x-axis and rotates counterclockwise. So this angle in the first unit circle is a standard position angle. Over here, this is not because we went clockwise, not counterclockwise. But if you were to draw this angle in here going clockwise, that would be a standard position angle. So if we were to start at the initial arm and we were to go around the full circle, that is 360 degrees, and we could go around the circle again, which would be 720 degrees, and then we could go around the circle again to get to 1080 degrees, and so on. You could go on and on forever. So that's what it says here. One full rotation is equal to 360 degrees, but P can rotate around the circle as many times as we'd like, n number of times. So here we are asked to draw a terminal arm that represents an angle of 50 degrees. So to do that, we're going to start at our initial arm. 50 degrees is acute because it's between 0 and 90 degrees. So it's going to be somewhere here. So I've drawn the initial arm and the terminal arm, which makes the standard angle of 50 degrees. So now we are asked to draw two other angles that have the same terminal arm. So the terminal arm is here. So to get there, the first time I just went counterclockwise by 50 degrees. So now what I could do is go around the circle one full time to get to 360 degrees, and then keep going 50 degrees more to get back to that terminal arm. So how I show that, so I say start here, I go around one full time, and then I keep going to get to that terminal arm. So that angle is then 50 degrees plus 360 degrees, which is 410 degrees. And now we need to find another angle that has the same terminal arm. So I could go around twice around the circle and then add that 50 degrees. But let's do an example where we go clockwise. So we're going to start at my initial arm and go clockwise to get to that terminal arm. So that angle is 50 degrees minus 360 degrees, which is negative 310 degrees. There's a couple different ways of looking at this. You can think of at the terminal arm I was at 50 degrees. So if I go around in the circle in the clockwise direction, I'm going to subtract 360. Or you can think of it from the initial arm and you're going clockwise almost 360 degrees, which would be negative 360 degrees because you're going the clockwise direction. But we're 50 short of that. So we actually went in the clockwise direction by negative 310 degrees. All angles in standard position with the same terminal arm are called coterminal angles. So we say that 410 degrees and negative 310 degrees are coterminal to 50 degrees. And there's an infinite number of solutions depending on how many times you go around the circle and in which direction you go. So in this example, we are asked to draw an angle of 130 degrees in standard position. Then find two other angles that are coterminal with that angle and illustrate the solution. So to draw 130 degrees, I will start at my initial arm and draw my terminal arm over here because 130 degrees is obtuse. So this angle is 130 degrees. So to find my first coterminal angle, I'm going to start at the initial arm, go around the circle one full rotation, and then keep going that extra 130 degrees. So I am at 130 and I add 360, which is 490 degrees. And for my next coterminal angle, you could add 360 degrees again, meaning you go around the circle twice in that extra 130. Or let's do another one where we're going in the clockwise direction. So you're starting at your initial arm, you're going clockwise, so you know your angles are going to be negative. So to get that angle, I'm going to say 130 degrees minus 360 degrees, which is negative 230 degrees. So again, we say 490 and negative 230 degrees are coterminal with 130 degrees because they have the same terminal arm. And the final question, it says, suppose P has rotated negative 870 degrees from the initial arm. How many rotations has been made? So we know that there's 360 degrees in one rotation. So we're just going to find out how many times 360 degrees goes into negative 870, which is negative 2.4. The negative means that we went in the clockwise direction, and we went around two full rotations and almost halfway more. So to draw that, I'm going to start at my initial arm. I'm going to go this direction one full time, and then another full time. And then 0.4 is almost 0.5 more, so about here. And so my terminal arm will be drawn here. And I will say that that is negative 870 degrees. And you can keep track by knowing you start at 0 degrees, then you go to negative 90 degrees, then negative 180 degrees, then negative 270 degrees, then negative 360 degrees, negative 450 degrees, negative 540 degrees, negative 630 degrees, negative 720 degrees, negative 800 degrees, and then negative 920 degrees. We wanted negative 870, which is between negative 800 and negative 920. So that just confirms that I'm in the right quadrant. And then part C asks what quadrant am I in? Our first quadrant is where X and Y are both positive, and then we go counterclockwise. So quadrant 1, quadrant 2 is where X is negative, Y is positive. Quadrant 3 is where X and Y are both negative, and quadrant 4 is when X is positive, Y is negative. So our angle is in quadrant 3.